Hello, and welcome to Data Science 96. Today we're going to be talking about the cloud. So, obviously you've heard of the cloud, right? Everybody talks about cloud computing and things, but it's not immediately obvious why that's super relevant to data science or even what the cloud is. So, the cloud is just other people's computer, right? So basically you rent a computer and it is in some data center, usually owned by Amazon or Microsoft or Google, and that's it.
Except, of course, that's not really true, right? The cloud has tons of advantages that make it really different than just someone else's computer. Fundamentally, that really is what it is, right? So those three big players and a bunch of others will rent you compute, but they'll also rent you services, they'll rent you software, and even the practice of how the renting is done allows a ton of flexibility that's really interesting. So, delivery of computing on the internet is really what the cloud is all about. So it's about being able to use someone else's computer that's remotely located. That could be servers, it could be storage, right? So big hard drives basically in the internet. It could be databases, networking, all sorts of different things. So what does this physically look like, right? What is the cloud? Well, here's one example of a cloud computer. So what you're looking at here is a rack mount computer. So the thing is maybe a foot by 2 foot, so fairly large box. And this one actually belongs to Dropbox. And what you'll see, each one of those little blue lines is a hard drive, right? So you are looking at a computer that has very little compute, or certainly doesn't have a video card or anything like that, but just has a ton of storage. On the extreme other end, you see things like this, where this is just a GPU farm. So same idea, this is a rack mount computer, but really this one is just around doing GPU-based computing. So there's all sorts of different configurations of computers, but they basically just pack a ton of hardware in there, and then they start putting them in these racks. The racks look like this. So each one of those bays might be, all those GPUs or all those hard drives, and you start looking at how many of them are stacked up, and this starts to be like a lot of hard drives or a lot of GPUs. This one's a rendering. This one's an actual photograph, right? So horrifyingly, you just end up adding more and more and more until it really becomes incomprehensible. So this is a Microsoft data center in San Antonio, Texas. It costs about $2.5 billion to build. And it consumes 250 megawatts of electricity. So over on the side, you'll see some huge backup generators on the front here, and a diesel tank, so that even if the power goes out, this thing can keep running for a long time. You also see a really small parking lot, right? Not that many people physically work here, and the ones who work here are mostly like swapping out failed components. So it's really these unbelievable data centers. And if you think about each one of those computers, the rack mount ones, and you start multiplying how many GPUs or hard drives or computers or whatever is in each one, processors, and then you scale up to a rack and then a row of racks and then a building this size, right? It's just mind-boggling. So let's talk about the benefits of cloud computing according to some cloud computing marketing materials, right? So one thing that's true is the cost is different, right? So if you have really inconsistent computing demands, so you need a lot of compute for a little bit of time, the fact that you can pay as you use it, that these things are elastic, can be really huge. You also don't have to hire folks to like install and manage and do electricity and all the rest. So it can be way cheaper. It also can add up really quickly. So the cost benefits of cloud computing are debated. The speed is a huge thing for me, right? So instead of, if I want a new computer, I don't want a GPU for doing some training. It's under a minute to get a GPU in a place where I can deploy stuff in the cloud, right? If I want to do that in the real world, all the hot video cards are sold out. I gotta go find one. If I want another one, I gotta get a different motherboard because my motherboard won't support. It's like a whole thing. And if you're in a company, your IT department will want to set it up and patch it and deal with all this stuff, and it could be a month before you get anything. And then another point that's really key is this global scale. So increasingly, there are laws about where data can be stored, right? So, for example, you might have banking data in Canada, and it's not legal to store that data outside of Canada. So one way that global scale is nice is you have those different geographic regions. Another way scale is nice is you can have as much compute as you can buy. So if you want to, rent just an enormous number of GPUs for a while to do a large-scale training, and you've got the money, you can do it. Cool. This photo's a couple of years old now, but I don't think things have changed a ton. I think that Google and Microsoft are both making advances towards Amazon, but Amazon is really, when people talk about cloud computing, that's the assumed answer. I'll also call it AWS, which is Amazon Web Services. Microsoft's cloud is called Azure, and Azure is also great. Google's is making huge strides lately, so I think they've really improved. I've worked in all three, pros and cons of all of them. If I were to start a new project today, I might think about the Google Cloud for data science stuff. They've got some really cool things. And then the Alibaba Cloud, if you're doing significant work in China, can be a really nice thing. One thing to notice, Oracle, the cloud provider that is in the very bottom corner here, so very little market share, very little growth, actually has Zoom on it. So they've really escalated their cloud compute in the last 6 months with the pandemic, right? Cool. So let's talk about, once we've got all these things, we pick a vendor, what can we get, right? So one way to think about this is this hierarchy of different sort of levels of abstraction. So the base thing you can do is you can actually just rent a computer or storage or network. And often these things are parted out. So you pick the processor, the video card, the whatever, you can put the stuff together. Sometimes you just get storage. Just say, I want a hard drive that I can talk to, right? The next step where things sort of become more automated and all that is called platform as a service. And that's really where you start getting, instead of saying, give me a computer, you say, hey, give me a database, or give me something that will automatically do a data pipeline or something like that. So there's still a computer in there, but it comes sort of configured in a nice way. One example of this that I like that's sort of in there is a lot of cloud vendors have a data science virtual machine. So you can spin up a machine and it will already have Jupyter, TensorFlow, R, PyTorch, all that stuff ready to go. So you don't need to spend a bunch of time getting things going. Super nice. The next level in abstraction here is really about serverless computing. So serverless really means that you don't even understand what compute and storage and things are happening underneath. So obviously there still are computers in there, but you just say, hey, I want you to run this code, and you don't know where it's running or what it's doing. That could be really nice for super intermittent jobs, or when you're just getting started or something. It's sort of a newer concept, right? It's been around for a while, but folks are still figuring out how to use it best. And then sort of the last one is you can often get software on demand. So if you want to rent or sign a license for some software, you can use a cloud version of a lot of different things. So we were playing with Tableau earlier in the quarter. Tableau is really it has a desktop version that you can download and install, but it also has an online version where it's running on Tableau servers, which are in some cloud somewhere. So you don't even see the virtual machine or anything else. It's just a website that you sort of pay for and get. So the actual things that you're renting come in a bunch of different examples. So we're going to talk about what those are. So in compute services, there's this idea of functions. So those can be individual, single-purpose triggered code in a totally managed thing. That can be really nice when you have just a simple task you want to do over and over again. There's also this idea of containers. So containers, Docker is the one you'll hear about most often. And that lets you wrap the code and all of the dependencies, so operating system and everything else, into a package. And that package can be deployed on a bunch of different platforms, so you can make multiple copies pretty quickly. So that's a nice way to get sort of reproducible software out in the world. And then a virtual machine is really just like renting a computer. So you can pick your operating system and the parameters, and you can like remote desktop or SSH in and install programs and run it just like your own server, right? So that's sort of from like most managed to least. With storage, there's a bunch of options too. So the most managed thing would be you can just say, hey, I want a database, right? And they'll spool it up. Sometimes you can say, I want a database that you totally take care of. And other times you say, initiate this database, and then I'll customize it and maintain it. Also on the storage, you can have just basically internet connected hard drive. And an important concept there is the difference between hot and cold storage. So hot storage is stuff you expect to be reading and writing from all the time, and cold is like an archive, a backup, something that's not just ready to go at a moment's notice. So physically, cold storage can look like they'll actually write something to a tape, a magnetic tape, and store it, and it can be days of recall time before they get it back. Great for sort of disaster recovery backups, but not useful for serving up a website or whatever. And then you can also just get a disk, and then you would want to like attach that disk to a virtual machine or whatever. So if you need more hard drive space on a server, you just rent a hard drive and slap it on there. I use the word rent a lot. Other people will say provision, right? So you sort of just request it and pay for it. There's also some custom data services. So these have been evolving quickly. Over the last year, I think some of them have gotten to the point where they're kind of compelling. Before that, they really were like one size fits all, and they're kind of more of a pain to get going than I thought the benefit. But there are these analysis platforms that give you sort of all-in-one stuff. I don't know that I've seen one that I'm super wowed with yet, but there's a lot of people doing a lot of work to improve that space. And if you have certain types of data, it can be great. So if you're running a store in Shopify or whatever, there's companies that will take in all your Shopify data and make really nice plots and analysis on top of it. And you just pay them for that. There's also batch processing. Batch processing is often called ETL, extract, transform, load. And the idea there is that you've got data stored in one system and you want it in a different system. Typically, that's like you have some production transactional thing that's actually running your website. So some database. And then you don't really want to do data science on that database because it'll slow it way down. So you have some other database that's better for the complicated queries that you do for data science. You also want to do some work, maybe when you pull everything out to clean it up, and so you'll schedule a task. And there are task scheduling services that can do all this. And each cloud's got its own different version of that. There's also streaming versions. One thing I should notice about this and point out about this is that there are often open source versions of all of these things also. So it really depends on if you want to just set up some computers and get everything going yourself, or if you just want to have someone else manage it for you. Typically managed stuff is a little bit more expensive, a little bit less flexible, and a lot less work. And then there are also some machine learning services. So we'll play with some of this first category, which is a pre-built interface where you can use the machine learning in an automatic way that's already made. So you've probably used like a Google Translate or something, where you put some text in and you get a text back in another one. There's all sorts of these that you can use that are just pre-made. There's also a bunch of machine learning tools. So things that do automatic machine learning, or things that help you track and deploy or whatever. I think these are stinky so far. They're either too complicated or they're super focused on something. But again, this is a space where everybody is investing really heavily, and somebody's going to figure it out and make it really nice. So that's a couple of different ways to look at the cloud services. But the thing I want to note is that all this stuff is super confusing when you first hop in, because, I said the cloud and then I listed like 50 different things. So if you go on Amazon's site, they have, it looks like 100 different products. And so you don't know right off the bat if you want to use, Kinesis or Google's BigQuery or all these different things. There's just tons of them. And so it can be pretty overwhelming at first. That's just totally true. And I recommend trying to find somebody who's done something very similar to what you want, get that working, and then start modifying it, right? So there's a lot of templates out there and examples. Also, these things are changing really quickly, and so you want to find one that's done fairly recently. So the last thing I'll note is that you need to interact with these services, and there's three primary ways to interact with cloud services. So one thing you can do is you can actually open up your console, right? Or command prompt or whatever, and write text commands to interact with these things. So typically you'll install some sort of program that lets you communicate with the cloud, type in your password, and away you go. You can start saying basically the command line like, hey, set me up a server, give it an IP address, give it this much memory, and do it all there. Sorry, that was the SDK. Right, that's the local command line version. The console is the actual website, so that's where you go. You log into the website, and you can control everything there. And then the third option is there are often client libraries for code. So for example, with Google or Amazon or any of these, there are packages for all sorts of different languages, but certainly for Python, that let you interact with these resources and manage them automatically. And they also have ones that give you a bunch of help to automatically do permissions and all that stuff, so it's easier to interact with in code. So you don't have to sort of write all the standard boilerplate to be able to use this stuff. So definitely take advantage of those when you're trying to integrate your code with these services. All right, one last thing. In the background of this picture is this Google TPU pod. So TPU is a tensor processing unit, sort of like a video card used in machine learning. It is an alarming amount. So there's 64, in each one of those columns, there's 64 tensor processing units, which is 11 and a half petaflops, right? So just one way to think about that is each of those columns has 4 terabytes of high-speed memory attached to that. So that's not hard drive or something. That's video RAM, basically, tensor processing unit RAM. So really just an unbelievable amount of processing. And you can just rent one of those. They are tremendously expensive, so you want to make sure that you have everything ready to go. Cool. That's it for today. Thanks.